Oh, here's a missed question. And the teacher side of me says, don't go over it. Um, it's something that they should, that they shouldn't hear from you. Maybe they can hear from a peer. But the mathematician side of me says, yeah, this is the this is what they're gonna want to hear. Basically, um, part of this question it is an issue of knowing how to answer questions, right? How to eliminate um, or discriminate between the answers and try to use a little deduction. So in a Harris poll, adults were asked if they are in favor of abolishing the penny. I don't know if you've heard about that whole argument that it costs more to make the pennies than they're worth, and so we're kind of like losing money on the deal. Anyway, we're not going to start the argument here, but look it up. It's kind of interesting. Among the responses, 1,263 answered no. Maybe they are just the penny lovers. They like the picture. 455 answered yes, and 365 had no opinion. What is the sample proportion of yes responses, and what notation is used to represent it? Okay, I'm going to jump quickly to the second part of the question. What notation is used to represent it? Now, you have in your list of approved notes for the test, you have this one that says statistic symbols. Well, use it to your advantage. I mean, I know the teacher side of me says don't say this. It's kind of teaching you how to answer multiple choice tests without really. Anyway, so go through the list and you should see that symbol. I mean, it's going to definitely be one of our common symbols. I'm going to feel pretty bad if I don't see it. Oh, there it is. Okay, p hat. So, zoom in here a little bit. There's that p hat symbol, and it says sample proportion. Sample proportion is p hat. So, um, that means that the only pair of these that can be right is either A or C. You can just eliminate B and D right away, because A and C both say that that symbol is used to represent sample proportion, and the symbol for P is not used to represent sample proportion. Actually, we usually use P to represent probability or population proportion, but in that case we usually use the capital P, go between those. So then how do we do the calculation part? So it's either A or C. Figure that out right away just by having your symbols list out and knowing what your symbols represent. And then you need to remember how p hat was calculated. Now I wish we could just explore this page a little bit more and find it here, but we're probably not, because that's just those are just symbols. So then maybe we could go through the formula and tables sheet and find it there. This was early on that we brought it up, and we might get lucky here. I am not. I'm seeing the usage of p hat, but I'm not seeing the definition. Now I know what it is, and you probably know what it is too. Unless you got this question wrong, which it was one of the most missed questions. So someone got it wrong. So instead I'm going to go to the review card. And I'm just going to quickly check. If I don't see it, I've just got to remember. And I got to think about how probability works. Well, here's a good example of how probability works. Probability of any event is calculated by S over N, the number of ways that the event can occur divided by the total number of simple events. So you can kind of use that as an indication. The notation is going to change, but let me see if they actually use our notation for p hat. Oh, we're getting closer there. There's a number of successes is denoted by x, and number of trials is denoted by n. And p hat is x over n. It's the number of ways you can have your successes occur divided by the total number of trials, or the total number of samples in the sample's simple events. So without looking, oh, there it is. Okay, I was going to say without looking any further, but there it is on our sheet. So if we are really familiar with these sheets, we can actually kind of move around, and obviously you don't have to waste time zooming on a piece of paper, but I do. P hat is defined by x over n. You just got to remember that x is the number of successes, in this case answering yes, and n is the total number of simple events. And in this case, those independent simple events are the actual people answering. So remember, there were some who answered no, some who answered yes, and some who had no opinion, but they were still part of the survey, so still part of our denominator. So what's the sample proportion of yes responses? Quickly find out the n value, which is 1263 plus 455 plus 365. So we've got 2083, and then make sure you're answering what they said. What's the sample proportion of yes? And yours could say, what's the sample proportion of no, or what's the sample proportion of no opinion? Our yeses were 455. Let me get that in there again. So the total was rounded to 3 decimals, 0.218. Now I bet that this 0.265 was for someone who was only totaling the yeses and nos and ignoring the no opinion, because they thought, well, they have no opinion, so they have no bearing on this sample. Well, obviously they have a bearing on the sample, because they were people that were surveyed, and they just didn't give us our binary response. And obviously then this doesn't fit into a binomial distribution, does it? Well, depending on how you worded it, but if you called success answering yes, and if you called anything else the other outcome, then you could kind of consider it binary, but really this is meant to be one of those non-binary situations, like what we had in chapter 5. So let me just check that. If we would have $12.63 plus 455, if we would have just added those, our denominator would have been 1718, and so then yes responses divided by that amount is 2.65. Yep, pretty expected. They're gonna try to get you, and they, who are they? They aren't anybody. Okay, it's just we put together some statistics questions to try to test ourselves, and there's no bad people out there. The ubiquitous they that are trying to get you. But anyway, no one's trying to get you. But if they were there trying to get you, it would be the first place you would have to be careful is the symbols, knowing your symbols, and in the second place, knowing your definition and having such an understanding of it that you don't accidentally, use the wrong divisor. Okay, so this was interesting. It's not letting me go down and select that. I'll just select right here, and then I'll scoot over. Alright, this is our question set number 75, and there it is. We were right. Obviously, we knew that.